Good morning. Welcome to AGRS Section 2. Today our lecture will be finishing up some of the details about reproduction, specifically artificial insemination. We'll cover the advantages and disadvantages, the specific techniques used in semen collection, synchronization, heat detection, insemination, and embryo transfer. Before we get started on that, just a quick little minute about poultry reproduction. We didn't study that a lot in the previous chapter, chapter 10 of the text, but poultry reproduction is significantly different than the reproduction of the farm animals we studied. First off, there is no pregnancy per se. The avian species lays eggs, and those eggs actually develop outside the body. So chickens don't nurse their young. They actually don't have a real well-defined estrous cycle, and they lay eggs through the cloaca. One of the interesting things about poultry is that while they are the eggs themselves are a food source, there also is some interesting genetics that have been tinkered with so that egg-laying hens can provide the eggs that the consumer wants. A quick overview of the poultry reproduction tract. I actually highly recommend that you take a look at this YouTube video, and we'll come back to this in just a little bit. It has a really cool 3D modeling section where it talks about each of the steps within the poultry reproductive tract. You can find that the majority of the reproductive tract lies against the back of the chicken. And so right under the lungs, you then see the follicles and the ovum winding on down then to the uterus. And the majority of the digestive system is kind of opposite it along the stomach. Kind of the path that things take. This diagram is a little bit more stretched out so you can see each individual part. But the infundibulum is where the yolk originally comes in, and then the magnum area adds the white to the egg. The isthmus adds the shell membranes, and then the uterus adds the final shell. When the vagina receives the fully formed egg, it is then laid through the cloaca. It takes 42 hours from the ovulation that creates the yolk to when the egg is laid. And if that egg is to be incubated, either by the heat from the hen or from like an incubator, that takes at minimum 21 days. Here's the poultry reproductive tract for a male or a rooster. The testes are within the body cavity. That's one major difference from the animals we've studied. And the penis is very different. It's more of a rudimentary nub. So that reproductive process looks a little bit different. It is different for waterfowl, and we see quite a bit of variation between species of birds. You should know that the sperm can be stored within the female poultry animal for a decent chunk of time. It's up to about 10 days in chickens, but for turkeys it's actually up to about 30 days. Again, take a look at this poultry reproduction modeling video because it has a really cool, some cool graphics that make that easy to understand. All right, on to our main focus today about artificial insemination. Artificial insemination is the name of the term for when we collect semen from the male and deposit it in the female reproductive tract. This is done naturally by the breeding males, but when it is done artificially, thus the name artificial insemination, it can be used in most livestock species, all under kind of differing circumstances. We definitely see it used in cattle, very, very frequently in the dairy industry. It is used very frequently in pigs as well, quite a bit less in sheep and goats, but it is used some, and poultry. Specifically, turkeys are almost exclusively artificially inseminated because the domestic turkey We have tinkered with the genetics on it over and over again to increase the size of the breast, because the breast meat is the most popular and brings the most money. And so now we have created such large breast meat muscles that the male turkeys actually can't physically inseminate female turkeys, and so that's done artificially. The primary advantage of artificial insemination is that you can use superior genetics and improve your herd even when that animal is not on site. So maybe you can't afford a bull, for example, that has really awesome genetics, but you can afford to inseminate a couple cows with that bull and increase your herd genetics that way. Some other advantages of artificial insemination include disease control. When you buy straws of semen, those bulls have been tested for all sorts of diseases and sexually transmitted diseases especially. And so we can prevent the spread a little bit that way. There is certain situations where injury occurs to both male and females in the breeding process, and artificial insemination can prevent that. It also allows us to use a sire that either has poor breeding habits or has been injured, especially in older bulls. Injuries to the hind quarter as a result of breeding are kind of common as they age, and this allows us to use the genetics of that male a little bit longer. When artificial insemination is used, there's a variety of different semen quality tests that are done, and so you can know a lot earlier if you have a male that's not breeding well or is not going to successfully cover many cattle. Whereas if you are using a bull, you may end up in end of the season or postpone your entire calf crop because the bull was not producing. Artificial insemination has been around for a very long time. There's actually record of it being used in 1780 to artificially inseminate some dogs, hunting dog type stuff. We then have record of it in the late 1800s for inseminating for the use of embryo transfer in rabbits, primarily for research. And then about 1950, we started to use embryo transfer successfully in sheep on a research basis. By 1951, embryo transfer became more and more common. Particularly, we see it here in the western half of the United States, common in cattle. By 1973, we were producing frozen embryos from cattle so that they could be put in recipient cows. For the most part, we consider the dairy industry within livestock to be kind of on the forefront of artificial insemination research because of their need to increase the milk production of cattle to be more and more efficient all the time. There are a few disadvantages to artificial insemination. It is a model of management that's far more intense. You're handling the animals a lot more. So if the animals are in a place where you cannot handle them, then that becomes problematic. The costs involved in artificial insemination are quite a bit higher in terms of labor, and you have to have the correct facilities and equipment. We have to be able to get and store semen, and then if it is not done correctly, sometimes animals have to be inseminated multiple times. The success of artificial insemination really depends on a few key things. The first is, can estrus be detected in a way that is effective and efficient? We need the male animals to have really high levels of fertility, and when that happens, then we need them to also have high quality semen. It takes a skilled technician to be able to handle the semen correctly to make sure none of that is affected, and also to actually inseminate animals in that way. In the bottom right-hand corner, you see a picture. This is what we would call a sperm viability test. And so the technician is looking for the mobility of the sperm, the counts, and things like that. AI is pretty prevalent in all parts of the animal agriculture industry, but we definitely see it happening more in some animals than others. If you'll note at the middle of that table there, dairy cattle, almost 80 to 90% of the animals are artificially inseminated. In the swine industry, about 85% of the animals are inseminated. 100% of turkeys are. But then when we start to look at sheep, you can see that really it's about less than 5% of the sheep industry uses insemination. That is primarily on a show basis or a seed stock production situation. And then we see that slightly higher in beef cattle. It would be interesting to see how recent this statistic is. I have a hunch that percentage for beef cattle has actually gone up in recent years as we have more and more technicians and the technology is more readily available. When you look at the line item there for horses, that one's really kind of interesting. It's very breed specific. There are some breeds that actually don't allow artificial insemination if the animal's to be registered. There are some breeds that do allow artificial insemination. So we see this kind of dependent on breed with horses, but not so much in the other species. For artificial insemination to work, we have to collect the semen from the males. And there's a couple different ways this can be done. What you see a picture of here is a stallion being collected with the use of an artificial vagina. And we'll look at a picture of that apparatus in another slide. Bulls, stallions, rams, and bucks are often collected in this way. Boars and poultry work a little bit differently. They require manual stimulation, and occasionally what's called an electroejaculator is used on bulls and rams if they are not collected very frequently. The top picture on this slide is a picture of an artificial vagina. You can see that on the left-hand side, the semen is then kind of dropped into a collection tube. We try really hard to scientifically keep that collection specimen very clean, keep oxygen away from it, because all of those are things that could harm the sperm viability. And then the picture on the bottom is what is used to collect some animals, and it's called a ram electroejaculator. Now, the number of times per day that a breeding male is collected greatly affects the viability of their semen. If they're collected too often, we find a dramatic decline in the semen viability, and that definitely changes the value of the semen. Bulls can be collected twice per day, 2 times per week. We see rams need to spread that out just a little bit more, several times a day. But several weeks time in between for rest time. And then boars and stallions is more of an every other day sort of schedule. Thoroughbreds are a little bit different. The thoroughbred industry requires live cover, and the females have to be bred during a certain season. So we actually see those especially higher power breeding males breeding mares 3 times a day during that breeding season. And at the end of each of those breedings, they do collect a small amount of semen to check the viability on site there at the farm. Oftentimes when we look at breeding fees, those fees, especially in the equine industry, are dependent on a live foal hitting the ground. And so if a mare is bred and then aborts the fetus or things like that, then the breeding fee is not paid. So both sides of the equation really have a vested interest in making sure that the animals are bred successfully. Turkey semen is collected 2 to 3 times a week. Obviously, the volume of semen collected is different in each species. This is what we call a semen straw. You can see the part on the left has to do with the application of the semen. The 3 little straws on the right are actually straws of semen. Now, for the semen to be put into the female, heat detection and AIing, specifically heat detection, has to happen. Heat detection can be tricky and time-consuming and expensive. There's a lot of different ways that it's handled. So we'll go through just a few of them. The first is that many times we use a process called synchronization before we AI. And that means that because animals' estrus cycles happen whenever biologically the body wants them to, we want them to happen at the same time. It's not economical to have an AI tech visit the farm once per day just in case an animal is in estrus. And so oftentimes we use prostaglandin and restart the estrus cycle. When you give prostaglandin, it restarts the estrus cycle, and then you can begin to AI at the correct time. Sometimes an item called a controlled internal drug release is used. It releases progesterone and then prostaglandin to restart the estrus cycle. Sometimes this is used for AI, sometimes this is used to shorten the birthing period for animals. This is a picture of a controlled internal drug release. We have to determine whether an animal is experiencing heat detection, we have to use heat detection to determine if an animal can be bred. And so there are many methods. Sometimes farms use a vasectomized male. There's a lot of pheromones that are emitted, so those animals react to each other differently. Sows can be determined by pressing on their back and their sides, and then sometimes patches are used. This is a good picture of a patch because what happens is animals mount each other, oftentimes even female to female. That's just a sign that they're in estrus and willing to accept the breeding from the male species. And so that patch put on the tail head can indicate that. We sometimes also just watch their behaviors, put them in pens next to each other. I know in many horse farms, they actually have a gelded male there to just detect heat in the mares before they go on with the breeding. When animals are inseminated, we have to know the time of ovulation. Fertilization can only happen after ovulation, and sperm are fairly short-lived, so we want to get this right. Species are very different in terms of their length of estrus cycle. And so as you can see on the screen here, cows are typically AI'd 12 hours after heat is first detected. Ewes, we aim for the second half of their estrus cycle. Goats happen, we want to AI them about 10 hours after beginning estrus, and sows at the beginning of the second day or end of the first day. Doing this too soon or too late would mean that we miss ovulation and the deposit of the sperm is kind of useless. When the insemination happens, this is kind of a picture of what goes on specifically in cattle. There's a video clip here in the next slides I would like for you to watch because it shows what that process looks like from the outside. Here you can see the inside diagram. The arm is inserted through the rectum, and the whole purpose of that is to be able to kind of hold in place the cervix, because that's the hardest part to get the straw through, but it's absolutely necessary to deposit the semen in the correct place. So definitely take a look at this video and then kind of watch how that happens. We will continue next time with a lecture and talk about embryo transfer. Have a great day. Bye.